Claude Certified Architect matters because it converts Claude knowledge into architectural judgment. Anthropic describes the foundation certification as a technical exam. It's for solution architects building production applications with Claude. The study path cannot be passive reading. It must train decisions: when to prompt, when to retrieve, when to call tools, when to evaluate, when to constrain autonomy. Most beginners collect tutorials, docs, and practice questions. They hope familiarity turns into readiness. That approach fails because exams test trade-off reasoning, not memorization of facts or code. Candidates must recognize constraints under pressure. In real enterprise settings, latency matters. Cost is a key factor in design decisions. Privacy requirements shape system architecture. Tool permissions affect what you can deploy. Context limits impact how much data you can process. Failure modes must be anticipated. Stakeholder risk influences every choice. The plan starts with replacing content consumption. It shifts focus to decision rehearsal instead. Claude fundamentals are just the starting point. The real challenge comes with safe, scalable design. A weak answer says simply add an agent. A strong answer defines the workflow clearly. It narrows authority to prevent chaos. It structures context for consistency. It adds observability for transparency. It proves quality through rigorous evals. True readiness means every answer explains why the system survives production. The fastest path isn't more hours, it's better sequencing of learning. Build a mental operating system first, then attach features to it. Every Claude capability is a design lever. Prompts shape behavior effectively. RAG supplies knowledge on demand. MCP connects systems seamlessly. Claude code changes how execution works. Evals measure reliability accurately. Caching transforms the economics of use. The learner stops collecting facts and starts composing entire systems. Start with the model surface. Learn about messages and system instructions. Understand context windows and their limits. Explore structured outputs and how they work. Discover prompt caching and its benefits. Learn about batch processing capabilities. Master model selection for your needs. Focus on what each surface controls. A beginner becomes useful by knowing this. One prompt shapes application behavior. The same prompt affects API cost. It also influences failure patterns. Prompting is not just decoration, it's the control plane for intent and role. It defines constraints and examples. It sets refusal behavior and output contracts. Study prompts as reusable system components. Don't treat them as clever one-off tricks. Move into context architecture next. Decide what belongs in the system prompt. Determine what belongs in retrieval. Know what belongs in tool results. And identify what should never enter context. Modern Claude systems use tools, not just text. Study tool schemas and error handling carefully. Review approval flows and MCP server roles. Understand how Claude Code manages permissions. Permissions control allowed tools, files, and domains. Sandboxing enforces OS-level boundaries for Bash. Treat tools as capability boundaries, not convenience features. A reg is not just a search box on a chatbot. It's a full knowledge delivery system. It includes ingestion, chunking, and embeddings. Then ranking, grounding, and citations follow. Freshness and fallback behavior are also key parts. Study when retrieval beats long prompts. Consider when memory creates risk. Explore how cache context improves economics. Anthropic reports prompt caching cuts costs by up to 90%. It can also reduce latency by up to 85%. The wrong instinct is to grant more agency first. Reliability must come before autonomy. Use eval datasets and golden answers. Run regression tests regularly. Implement human review gates. Enable thorough logging. Test with red team prompts. Prepare incident playbooks. Anthropic reports 93% approval for Claude Code permission prompts. This shows friction is real, the lesson. Don't remove oversight. Design oversight intelligently. Run the plan like a sprint. Each week focuses on one domain, one build per week, one failure review, one scenario drill. Read the docs carefully. Implement a tiny system. Break it deliberately. Then write the architecture answer. This rhythm turns abstract ideas into instincts. By the end, you have a portfolio of decisions, not just a pile of notes. Practice questions should come after the system is built. Use mock exams to find blind spots in your design. Look for overusing agents or skipping evaluations. Check if tool permissioning is being ignored. Watch out for trusting retrieval without grounding. Avoid optimizing prompts while ignoring cost. Review every missed question as an architecture defect. Your score matters less than error patterns. Patterns reveal what still fails under pressure. Readiness is not the same as confidence. It's the ability to choose a design under ambiguity. You must justify every architectural decision made. You also need to constrain options effectively. For any scenario, you can identify the user need. You can define the system boundary clearly. You know the context strategy used. You understand the tool policy applied. You can name the evaluation method. You manage cost control properly. You have an escalation path ready. This shift marks the move from beginner to architect.